Yeah, good morning everyone. So in today's video lecture, we will discuss structures in C language. So we try to understand what is a structure and what is the purpose of using a structure in C language. So based on your previous knowledge in C programming, you might have already used variables, you might have already created arrays also to store a collection of data, especially arrays are used to store collection of similar data. Now, for example, you want to store various data items which belong to a single entity or which belong to a single person. For example, there is an employee. So, employee ID, name of the employee, salary of the employee, right? His department, his designation, like that, various different data items, but they all belong to a single unit or a single person. If you want to store such kind of data, different data items as part of a single data unit, then you have to use a structures. So what is a structure? Structure is collection of various data items into a single unit, and structure is used to create user defined data type. So the way we have just now defined, like employee has got ID, name, department, salary, various attributes. I can put them together into a new data type called as employee type. So in order to create our own data type, we use something called as structure, right? Let us see how to create a structure. What is the syntax to create a structure? So friends, this is the syntax of defining a structure. So one important point, you need to define structure outside the main, right? Not in the main function. And this is the syntax which is present on the screen. Struct is a keyword. Employee is name of the structure, right? You can say employee is the data type which we are going to create now. Under employee type, I have three different attributes or members, you can say members of the structure: ID, which is an integer, name, which is a character array, and salary, which is of type float. So this is how you define a structure. But one very important point is, the moment you define a structure, memory allocation for the structure is not done. It is just a data type which you have defined. The way you have int, float, char, long, and other data types, double, etc., which are built-in data types in C language. Similarly, we are creating our own data type called as employee. So when you want to store an integer, you create a variable like int x. Similarly, I need to create variable for employee data type. When I create variable for employee data type, then only memory allocation is done. Simply defining a structure does not allot any memory, or no variables are created. So employee is a data type, similar to int, float, char. Employee is a data type. The way I create variables of type int, float, char, etc., similarly we will create variables for employee type also. Now, how much memory should be allotted for this variable of employee type? Like integer, generally it is 2 bytes, right? So similarly, like float will take maybe 4 bytes. Similarly, how much memory will be allotted for employee type? It depends on the members of that data type. So here in employee type, if you observe, I have three members. I have created three members in employee type. ID, let us say integer is 2 bytes in this machine. So for integer type, 2 bytes, 20 characters, so 20 plus 2, 22 bytes, and float, let us say 4 bytes in this machine. So 2 plus 20 plus 4, 26 bytes of space will be allotted for the variables of type employee. Okay, so how do I create variable of employee type? Let us try to understand that. So creating a variable of type employee. So there are three different methods which are present on the screen. Struct employee E1, right? Since employee is not a built-in type, until unless I use that struct keyword, compiler will not be able to understand that employee is a user defined data type. So whenever you create variables of type structure or a user defined data type, definitely you should use struct keyword before that data type name. So struct is the keyword, employee is the data type, E1 is the variable of type employee. So how much memory will be allotted for employee? How much memory will be allotted for employee? 2 bytes for integer ID, 20 bytes for name, 4 bytes for salary, total 26 bytes should be allotted. Now, see the second type of declaration. I may not, I generally I will not have a single employee in any organization, right? So suppose I have 10 employees, then what need to be done? I can create an array of employee type. The way you create a normal integer array, similarly, I can create an array of employee type. So here in the second declaration, E of size 10 means I am creating an array of size 10, and in each member like E of 0, E of 1 up to E of 9, every variable is capable of holding one employee information. Means E of 0, under that I'll get 26 bytes wherein I can store details of one employee. E of 1, I can store details of second employee. Like that, E of 9, I can store details of 10th employee. So this is a typical array concept which you have already studied, and I hope you are aware of arrays. And see the third type, this is for dynamic memory allocation. For example, in advance, I may not know how many employees are there in a company, because in arrays, the problem is you need to mention the size. What is the size? 10 I gave. What happens if my employees are 15? I can't store another 5 employees details. Suppose I have only 3 employees, but the size is 10. Then I am wasting the memory. So in arrays, since it is static memory allocation, the problem with arrays is you need to guess the size, which is not possible every time. So what will happen? Either it may lead to shortage or it may lead to wastage of memory. So precise allocation can't be done because of arrays. So what we can do is we can go for dynamic memory allocation, wherein we will ask user to enter the number of employees. It can be 20, 30, 40, or 50. Then based on that, using functions like mlloc or clloc, dynamic memory allocation functions, you can create memory for a specific number of employees, and that piece of memory is pointed by E. Star E is a pointer which can point to that piece of memory. So if you are going for dynamic memory allocation kind of thing, this is the third example. So in how many ways you can create employee type or a variable of any structure, means there are three different methods: first, second, third, which we have seen. Now before we move on, there is an important point to be observed. Please note this one. How many bytes we have expected for integer? 2 bytes in this machine. So 2 bytes for integer, 20 bytes for this character array. 2 plus 20 is 22. Another 4 bytes for floating point variable. Total 26 bytes of memory should be allotted. This is what we have discussed, right? Now, please note, there is an important situation, there is an important point to be noted. Sometimes you may get anything more than 26 also, maybe 1 or 2 bytes extra. So it may happen. Suppose I am expecting like 26 bytes will be allotted. Sometimes I may see, if I use the size of operator and if I see the size how much was allotted for E1, then maybe I may see 28. So if that happens, so don't think like something went wrong. Actually, it is 26 bytes, but you got 28 or 27. Please don't think that something went wrong. It can happen. I'm not saying every time it will happen, but it can happen. Let us understand the reason behind, right? So please observe this. See here, this int is, imagine this box represents my main memory, right? Each cell represents 1 byte. Imagine I wanted to create a structure with two members, only two members, one integer and one float. Imagine operating system has allotted these 2 bytes. See these arrows where I have written int. Operating system has allotted these 2 bytes for my first member of the structure, integer. Imagine I don't have any other member. I do have only int and one more float type. Now what will happen is, please observe here, after this integer, this particular cell is actually empty. Now what OS could have done is, it had an option to allot this first cell for my floating point variable and remaining 3 cells in the second row, in this row. Means continuation, without wasting space, continuation it could have allotted. Then what will happen is, 2 bytes per integer, then 1, 2, 3, 4. This 3 bytes of second row and the last byte of this one, this integer one. So total 6 bytes would have been allotted, but it will not be done like that. What will happen is, please observe, integer 2 bytes memory is allotted, and for floating point value, instead of assigning 1 byte in one memory location, another 3 bytes in another memory location, what computer will prefer to do is, instead of assigning like that, it will try to assign all 4 bytes in the same row. The reason for doing like this concept is called as padding, right? Because we are intentionally leaving this memory byte. The reason behind is, if my floating point variable is allotted space in two different memory locations, like 1 byte is in second row and remaining 3 bytes in third row, in that case I need to generate two different addresses to access that memory location, which will be very tough. Means with respect to performance, it is not a better option. That's the reason, in such cases, if this kind of situation arises, what will happen is, this byte will be skipped and the next row 4 bytes are allotted for float. Since this byte was unused and it is skipped, but still it can't be given to anyone else, because it started, see, my integer has started here and it ended here. So this extra byte which was not used, went unused, will also be counted. So what finally happens is, my expected memory allocation is 2 plus 4, which is 6 bytes, but what was actually allotted is 2 plus 1 plus 4, 7 bytes. I know that 1 byte was wasted, it was not utilized, but instead of generating two different addresses for same data item, I prefer generating only one address. That's the reason we are ready to compromise on the size but not on the performance. That's the reason you got 7 bytes in this case. And obviously, this may not happen every time. That's the reason I'm telling you, if at all you see the size of the structure when memory allocation is done, you will get the standard sum of all these members size only. But rare case, sometimes you may see something 1 or 2 bytes extra allotment. If that happened, then it is the reason. Padding is the reason behind it. So friends, I hope you got a fair understanding of what is a structure, how do we define a structure, how to create variables of structure. So let us go back and type a couple of programs to understand how structures are actually processed, right? So let me explain you through a couple of examples. Let me take you to Turbo C editor. Yeah. So friends, let me save this file with the name strdemo.c. Yeah, structure-demo.c. So I'm creating a structure here, struct emp. Let me call it as emp, means employee. So friends, please remember, whenever you define a structure, near this closing flower bracket, there should be a semicolon. This is compulsory. Most of the time people forget to use a semicolon here, which will flash you an error message. Now please observe, I'm creating a member of the structure called as int id, then float maybe char name of size 20, then float salary. Three variables I have created as part of this structure. This is what we have seen in our presentation. Void main, right? Now I'm trying to create variable of this type, emp e1 or maybe e, right? Then what I'll do is clr scr to clear the previous screen's output, previous program's output. Now, what I'll do is I'll ask my user to enter details like printf, enter ID, name, and salary. Since there is only one employee, I am not mentioning the count, and let me take that input scanf. Percentile D for integer, percentile S for string, percentile F for floating point variable. Then I'll write ampersand E dot ID, comma E dot name for string. Ampersand is not required. I hope you know that reason behind it. So E dot, what's the third variable? Ampersand E dot salary, right? Now let me print whether to check whether whatever I have entered, was it properly collected by the program or not. So I would like to print my data. So let me print this by writing e dot id, e dot name, e dot sal. You know why get ch is used. So let me save my program, save, compile, run. So it's asking me to enter ID, name, and salary. Let us say ID is 1, name is Kiran, salary is some 5678.9. Right, friends? So this is how we could create a type of a variable of type employee, which is a user-defined data type. So let me come back and make a couple of changes to this program. So please observe this program struct emp. This is how I created a structure with three members in it. And if you want, you can see the size also. Let me show you the size. Printf percentile D. Yeah, I'll write it on a new line. Size of EMP type is equal to percentile D, and I'll write, I use size of operator. You know very well what size of operator does. It will find the size of memory which was allotted. So let me save it again. Let me run this one. Employee ID is 1, name is Ram Mohan, and the salary is 89, something like this. Size of EMP type is 26 bytes. So friends, it's clear like it is allotting the required amount of space. At times you may get something more than that. Then you should not get confused like why I got something more than 26. It is purely because of padding, and you know what is padding, which we have discussed now, right? Now let me make couple small changes to this one. I would like to create an array of this one. Maybe I would like to enter details of three employees now. So instead of asking enter ID, name, and salary, I'll make some changes in the message also. Enter uh, details of three employees, including, means I'm telling what kind of data is expected, including ID, name, and salary. Right. Now you know very well, since three employees data I am collecting, this single scanf is not going to be, so it will not serve my purpose. So I need to write a loop, because three times I need to collect the input. For I equal to 0, I equal to 0, I less than 3, I plus plus. So I'll write this scanf here, scanf percentile D, then percentile S, then percentile F. Now friends, E of I should write ampersand here because it is an integer type. E of I means 0 initially. So E of 0 represents my first employee dot ID comma E of I dot name comma E of I dot, since it is ampersand float, so I need ampersand E of I dot sal. So this function this for loop will run thrice and it will take employees of three. It will take details of three employees. Now once again I'll write a loop to print the same details for I equal to 0, right? So I'll write one print statement, printf backslash n percentile d percentile s percentile f. I'll write e of I dot id, e of I dot name, e of I dot salary. Now friends, let me save this. Let me compile this. There are no errors. Let me run this. Now please observe carefully how the program behaves. Previously, I have entered only one employee details. I created only a single variable. Let me check how the program behaves when I try to insert array of employee details, right? So ID, let me start with 1, name is Kiran, salary is some 98, something like this. See what happened. The moment I have executed my program, it is expected to take three inputs. For loop is properly written to take three values, but there is no problem with the for loop. You can see the count for I equal to 0, I less than 3, I plus plus. But why my program could not read the second input? I don't know what happened. So let me check. Let me go back to that output screen by pressing Alt F5. Oh, what happened? Please observe. So in the Alt F5, when I want to go back and see what happened, why program terminated abnormally, it shows me an error message in the scanf statement. It says floating point formats not linked. Friends, this can happen. It may not happen in every type of compiler, but in compilers like GCC and Turbo C, this can happen. Floating point formats are not linked. If this problem arises, what you have to do is you have to create a function. It's a dummy function, right? This function which I am writing has nothing to do with our structure program, only to handle floating point not linked error. I am writing this particular function. So semicolon, that's it. So this piece of code, this function has nothing to do with your program. It is only to handle that error, right? So it has nothing to do with employee data type. Now let me save this program again. Let me run this. Yeah. Enter details of three employees. Employee ID is 1, right? Name is Kiran, salary is 999. Employee ID 2, name is Ram, salary is 8989.8. Employee ID 3, name is Sham, salary is 8978. Got it. That's it. Okay, so this is how you can create an array of employees, right? Now, friends, a small point to be added. Now, for example, I would like to store address of an employee, right? Now, what I can do is I can write a structure as a member in another structure. So, whenever you put a structure as a member in another structure, it is called as nested structure. So, please observe this. I am creating a structure called as struct address, right? Int flat number, then character array street of size 20, then character array city of size 20, then character array pin code of size 10. So friends, I created one more user defined data type called as address, because address itself is not a single unit. It has got a lot of things like flat number, street, city, pin code, etc. Now there will be an address for every employee, right? So I want this address to become a member of my structure. So I'll write like this: struct struct address is also a member. Now address is a structure, you know that. Now struct address is a member. Address is the data type. I should create a variable, so I call it as add. The way int id is there for address, there is a variable called as add. So friends, now struct address is the data type, add is a variable of that type, and it is also a member of emp. So nested structure means, let me give a name to this one. Let me give a name to this piece of code. I call it as nested structure demo, right? So here address itself is a structure. So address is a structure and is a member of EMP. Right, friends? So now let me see how I can insert address details also for all these three employees. So here I'll write ID, name and salary. So here in the message I'll write ID, name, salary and address details. Now what I'll do is my for loop will run thrice because I have three employees, but see what are the format specifiers need to be added. I have flat number, which is percentile D. I have street, which is a string. I have city, which is a string. I also have a pin code, which is also a string. So these many format specifiers got added. Now I have how many members? I have total, see here, please observe. In EMP structure, there are four members. In EMP structure, there are four members. Three members are integer, string, and float salary. Then the fourth member is a structure. In that structure, there are again another four. So 3 plus 4 total 7 inputs I should give for every employee. Now, how do I collect it? I should increase the inputs in my scanf. So first one was employee ID, second one was name, third one was salary. Now, comma, what are the address fields? Ampersand E of I represents array index dot ADD is the member, which itself is a structure. Inside ADD, flat number is the member. So E of I dot ADD is a structure dot flat number, comma. Then what is the other parameter? E of I dot ADD dot street. Street is a string, so ampersand is not required. E of I dot ADD dot city. It is also a string, so ampersand not required. E of I dot ADD dot pin. It is also a string, so I don't need to write ampersand there. So this is how my for loop will read all 7 inputs for every employee. While printing, obviously, I need to add all those things. So street number, flat number is an integer, then all are strings. Street, city, pin code, right? So I need to add them. E of I dot add dot flat number, E of I dot add dot street, E of I dot add dot city, E of I dot add dot pin. So I hope you understood. We have added another 4 elements, that too using nested structure concept. Alt F save. Let me compile this. There are no errors. Of course, I got a warning saying that P is assigned a value that is never used. This will come because of that function which we have written to address that floating point formats error, and this warning will not create any problem. You can ignore this warning. Let me run the program. Enter details of 3 employees. Now ID is 1, name Kiran, some salary Then flat number 524, city, street, James Street, city is 40, pin code is 5 lakh 70, something like that. So this is my first employee. Second employee, Ram, salary is something. Now please observe, I got the same issue here while reading the inputs. So let me go to Alt F5. Did you notice while entering second input to Ram, my program terminated abnormally and started printing something, right? Now let us observe and let us address this issue also. So in the scanf, while reading in details of second employee, I got this problem. So let me check the scanf. Percentile D, percentile S, percentile F, followed by percentile D, which is for flat number, then all are strings, right? So let me check whether I wrote this properly or not. So first of all, let me check the variable names, what we have given inside address. Flat, number, NO, street, city, and pin. Right. So E of I dot ID, E of I dot name, E of I dot salary, then ampersand E of I dot ADD dot flat number. Ampersand is required here because it is an integer. Then E of I dot ADD dot street, E of I dot ADD dot city, E of I dot ADD dot pin. So these are all seems to be fine. Similarly in printing part, yeah, ID, pin, city, street, flat number, save. Let me make it 2, because every time to debug I need to type lot of inputs. So let me make it 2, Alt F, save, yes, compile, run. One, Kiran, some salary, flat number 4, some street, some city, then pin code. So, see, it started taking the second input details also. Then some salary, then street number is 45, then some city, some street number, some city, and some pin code. That's it. So it's working, right? So in order to reduce time, I have just taken 2 inputs. Similarly, if it is 10, 20, whatever it is going to work. So friends, this is a demonstration of a nested structure. How do I use a structure as a member of another structure? So I hope with this example, you understood how to create structures, how to use, how to create variables of your own type, and also how to write nested structures, right? So just go through this example, go through this code, right? And when you try to run this on your own, obviously you will get it. Make sure you write this dummy function to address that floating point related whatever runtime error we got, right? So friends, let us go back to that presentation. Yeah. Now, after nested structures, there is one more important topic called as self-referential structures. In C language, a self-referential structure is a structure that contains a pointer to a variable of same type. This allows structure to refer to itself. Please see this one. Struct node, int data, struct node star next. Friends, this star next is a pointer of what type? Same structure type. So what will happen if I create a structure like this? You can have any number of members apart from this pointer. When there is a pointer pointing to same structure, pointer which is capable of pointing to same structure, then it is called as self-referential structure. Apart from that pointer, you can have any number of other members. In this case, I created only one integer data member, right, which is called as int data. So how it will look? See, it will look like this: data and a pointer. What this pointer can do? This pointer is capable of pointing to another structure of same type. Means if I have something like this, data and pointer, let us say data is 10, this is a pointer. So if I create a structure like this, what this pointer can do is, please observe this pointer is capable of pointing to another structure of same type. Here, what is the name of my structure? Node. So what I have done, I have created a node like this. This is the data. I have stored 10 and there is a pointer. What this pointer can do? Pointer can point to another node because it's a self-referential structure. No, this pointer can point to another structure. So suppose I have something called as 20 and there's a pointer in that node also. So what this pointer can do, it can point to another structure. So like that, I can create a linked data structure like this. And for example, after this third node, imagine I don't have anything. I don't have anything to store. In that case, we can write null here. Right, friends? So this kind of structure is called as self-referential structure. Let us try to create this self-referential structure also. So let us go back to TurboC editor and let us do this one. So let me save this. Okay, self-referential structure.c. So friends, I am creating something like this: struct node, semicolon is mandatory. I create one data item called as data, then struct node star next. This is a pointer. Now what I'll do is void main. So friends, I am trying to create this kind of arrangement. I create 3 nodes. First node will contain 10 and its pointer should be pointing to second node. Second node has a pointer pointing to third node. Third node will not point to anything else. So this kind of arrangement I would like to demonstrate, and I'm going to write a program for that. So friends, memory allocation is not yet done. You all know that very well. So what I'll do is I will create, right? I will create a structure element like this, struct node. I'll create pointers, right? First, second, comma, third, and let me write one thing called as start. So I'm trying to create 4 pointers of type node. These 4 pointers will be able to point to these nodes. So what I'll do is I'll write CLR SCR to clear my previous output. Now I'll try to create nodes. How do I create node, right? Since there is a pointer, I'll be using the concept of dynamic memory allocation. So what I'll do is, friends, I will create memory. I'll create that node using malloc. So first is equal to malloc of size of struct node. So by writing like this, I am able to get memory which is of size struct node. Since malloc returns me the address in a void pointer, I would like to convert it into struct node type. Alt F, save, compile, no errors, right? So friends, first is a pointer pointing to a new node which was created. So it's a node which contains data as well as a pointer. In that data, I would like to store something. So I'll write like this: first dot data is equal to 10. Friends, I am trying to create whatever we have seen in the presentation diagram. Same thing I am trying to replicate. So if I want to create second node, what should I do? I'll write this line once again. I write this line once again. So what I will do is Alt E, copy, then Alt E, paste. So let me run this. Since I wanted 3 nodes, what I'll do is 3 times let me paste this. So here what I'll do is, friends, I'll assign these things to three different pointers, first, second, and third. So what I have done is, using first, second, third, I have created 3 pointers, data pointer, 3 nodes I have created. In each node, there is enough space to store one data item, integer, and another pointer. So friends, initially what I have done is, first dot data is equal to 10. I'll write second dot data is equal to 20. Third dot, this symbol is called as dereferencing operator or select operator. Third dot data is equal to 30. Right now, now this code which I have written as of now, it is the same as creating 3 different nodes, but as of now they are not connected. As of now they are not connected. So what I want to do, I want the first node's pointer to point to second node, and second node's pointer to point to third node. That is what I want. So that assignment of pointers is not yet done. Let us do that. So friends, I'll write start is equal to first. So first node which I have created, its address is also copied into start, so that I understand that is the beginning of my linked data structure. Now what I will do is, I'll write like this: first hyphen, right? What is the another element in the node? We have something called as next, which is a pointer, is equal to second. Means the first node has got 2 things, data and pointer. Data is equal to 10, that we have written. Now its pointer is pointing to second. So let me write this here so that it will be, more meaningful. First dot data is 10, and first dot its pointer will point to second node. Second node's pointer, which is next, will be pointing to third node. And for third node, what I would like to do is, its pointer must be pointing to null. Means it should not, since we have drawn the diagram in the presentation like 3 nodes, and third one should not point to anything, that is the last node. Since I am using null, this stdio.h is mandatory. So friends, this is what I have done. Alt F, save, Alt C. See, there are no errors. Only one warning saying that start is assigned a value that is never used. No problem, I'll be using it now. So how many nodes I have created? I have created 3 nodes called as first, second, third. And start is a special pointer of same node type, of course. Start is pointing to the first node also. Why I want start to point to first node is, I want to run a loop and I want to print all those values 10, 20, 30. So I want to start from the first node. That's the reason start is assigned with first. Now please observe, while start, I'm writing this loop to print the data. While start not equal to null, what I'll do is, I'll printf. What are the data elements? Only one integer, right? Which is start hyphen data. Now I'll increment this pointer, start hyphen next, start hyphen Start plus plus, we can write start hyphen next is equal to, sorry, start is equal to start hyphen next, like this we can write, right? Or else you can say start plus plus also, right? Alt F, save, Alt F, compile, statement, sorry, this is semicolon, right? See here friends, 10, 20, 30, I'm able to print it. What I'll do is I'll use a new line. Yeah, 10, 20, 30, right? So if you want to be displayed like a list kind of thing, what you can do is you write like this. Yeah, so that you get that feel, yeah, 10, 20, 30. So friends, please observe here. Let me explain you the code again. So struct node, I created a structure with two data members. One is a normal integer. Another one is a pointer. Another one is a pointer called as next. And it's a pointer of what type? Struct node type. So when I have a pointer as a member, and that to a pointer which is pointing to the same node or same structure, then we use the word self-referential structures. So friends, this is very, very important, and it will be used in linked list to create linked list data structure, which is very, very important data structure. And in fact, we are trying to just mimic that linked list type only. So in the void main, I am creating 4 pointers of type struct node. And in that, first, second, third, these 3 pointers I am using to create 3 nodes, and memory is allotted dynamically using MLOC, and I am storing the data. First dot data equal to 10, first dot next equal to second, second dot data is 20, second hyphen next is third, third hyphen data is 30, third dot next is null. So what I have done is I created 3 nodes and I have assigned the data, and I have also assigned the pointers. First one's pointer will point to second one, second one's pointer will point to third one, third one is pointing to null. And in order to run a loop and print all those values, somewhere I should begin. So I copied the address of this first node in another pointer called as start, so that I can treat it as starting node. Now what I have done, while start is not equal to null, I have continued to print the values start hyphen data. Then I've incremented the pointer. How do I move the pointer? Start is equal to start hyphen next. So what is there in start hyphen next? It is a pointer pointing to second node. That will be copied into start. So again, it will go to beginning of the loop. Since it is not equal to null, it will print the data of second node. Then again pointer second node's next, start hyphen next will point to the next value of the second node, which is address of third node. So that is copied into third start now. So start will print the third node value also. After that, what is there in the next value of third node? Null is there. So it will stop. So like that, it will print all 3 values and it will come back. That is what we have seen in the output. So friends, I hope, right, whatever you are seeing on the screen, 3 data nodes, 10, 20, 30, along with their pointers, that is what we have actually created now using self-referential structures. So friends, this is all about structures in C language, one of the very important concept in C, and lot of user-defined data types you create using structures, and hence structures are very, very important. The whatever examples we have discussed, probably it will be good enough for you to get a complete understanding of structures. I hope you will practice the same thing, because without practicing, right, as long as you see these videos, you will not understand anything. So please try to implement all those programs which we have done, and also practice a few more examples by making some changes to the programs which we have done. Like employee type I have created, you create a student node, student data type, and then start working on it. So please practice programming, please practice by taking a lot of examples. There are a lot of questions in the exercise part of the textbooks also, like the Yashwant Kanitkar is a standard textbook which I recommend every time. In that again there are exercise problems for every topic. For structures also there are very good examples. So first of all, try these examples in Turbo C. After that, take up the exercise problems and solve them, right? So then you will get a complete understanding on structures. Okay, thank you. Keep practicing programming. Thank you very much.